algebra, nature of the roots. Okay, we will start sharing all sorts of good resources in the Classroom app. So you don't want to miss out. You're going to get FOMO. All right. So to start this topic, it's important that I check your basic skills, and if they're good, we'll move past it quickly. But the first basic skill is, can you expand and simplify? So here is a multiple choice question where you're given some terms and you have to multiply them out and simplify. Which of these four options would you choose? A, B, C, or D? Which of these four options would you choose? Pop your answer in the chat as to what you get if you expand and simplify. I'll give you a little hint. That would be my step one. Watch out for the negative times a positive is negative. And now you have to think about, are there like terms here? So I think those are like terms, and I think those are like terms. So 8x minus 6x is 2x, and 16 minus 15 is 1. And so my answer would be D. Okay, so that is the basic multiplying out. I'm going to give you a more difficult one. I'm going to say, what if I said, could you multiply out the following? This is called a binomial. It's two terms. This is a trinomial, although they're all knitted together. If you multiply this binomial by this trinomial, what do you get? And then once you're done, I want you to tell me in the chat that you're done. So we are expanding and simplifying x plus 2 times x squared minus 2x plus 4. Can you do that? And once you're done, you let me know in the chat. It's always good to go over basics. I'll be back in 2 seconds. I just want to get something. All right. So if we multiply out this by this, this by this, this by this, we will get x cubed minus 2x squared plus 4x. And then if we multiply this, we get plus 2x squared minus 4x. And what's the last one going to be? 2 times plus 4 is going to be 8. So then we are looking for like terms, and we notice that minus 2x squared plus 2x squared is 0. 4x minus 4x is 0. And so this all goes down to x squared plus, sorry, x cubed plus 8. And so just to show you the difference, if we wanted to go from here to here is to multiply out and simplify. If we went from here back to here, that would be called factorizing. We would write this as a product of factors, which is what it was in the beginning. And so this is the sum of two cubes. That's why it worked out so neatly, because it was the sum of two cubes, which is a technique we can use to factorize. Give me a thumbs up or a happy face if you followed that. Give me a thumbs down if you didn't. Okay, fantastic. All right, well then let's move on to this one. Let's move on to the technique of factorizing. So now I want to know, the first technique we need to practice for factorizing is called the highest common factor, or HCF. Tell me which option of the four you think is the highest common factor for that question. What is the highest common factor for that question? So if we look at it, we definitely see there's a 5 in common, but there's also an A in common. And so if we imagine factorizing this, the 5A would be the correct answer, so it would be C. But we would also have, just to complete it, we would have 3B plus 4. So that gives me the 20, and then I need another A. So that would be the whole factorization of this. And let me just make up a little bit of a harder one here to test your factorizing out. Okay, that's a harder one. That's another example of using HCF. I'm going to make a custom one up for you guys. So if I said 21a cubed b squared minus 14ab squared, can you factorize that for me? And tell me done. You're done in the chat when you're done. So we scan for the highest common factor here. There's definitely a 7. There's definitely an A, and there's definitely a B squared. But now what goes in the other bracket? Well, we need a 3 to get all the way up to 21. We need another A squared, and that takes care of these two, and the B squared's already there. And here we have minus 2. So that's the minus 14. Then A times over, there's an A already, and then there's a B. So that's actually just going to be that. 3a squared minus 2. Let me give you one more. If I said to you, what is let me just do this. I'm making one up for you. So minus 3a x plus 2 plus 7b x plus 2 squared. Could you factorize that for me using the highest common factor? Now, it's a bit harder, so I'll give you some time. And I want you to think about how you would factorize that using the HCF method. And then just say done in the chat when you're done. There's going to be one sneaky thing that I think you all notice is that there's definitely a common factor of x plus 2, but watch out for this one at the end because it has a squared. And you want to think about how that, who would like to, in fact, I would love to hear someone share with the group how they would approach this. So just pop your hand up if you're willing to contribute to the team. Share your thinking. You don't have to get it right. The value is just in sharing your thinking with us. How would I, let's pretend I've had temporary amnesia and I've forgotten how to deal with this last term. I'm feeling a bit scared. Who can help me out here? Who can share some knowledge with me? Pop your hand up if you're willing to share some of your wisdom with me. What do you think, Amy? What do you think, Simtaya? Stephen? Arson? Sange? Zaninda? What do you, I think I'm pretty confident I could do this. I'm pretty confident I could do that. But now it gets a bit more exciting. Who wants to pull the trigger and share their thinking with this next one? You can do it. Okay, I'm going to be brave and say 7B, but there's something missing. Something else needs to still be involved. What still needs to come in here to complete this? You get a virtual high five if you can get this. There's something missing. Who wants to take the glory? So the key thing to think about is if I look at the moment, if I look at what that x plus 2 squared is, it actually means the same as x plus 2 times x plus 2. And when you took out this x plus 2, what you left behind was not just a 7b, but you left behind an x plus 2 as well. And so that would look like that. Now that's a toughie, but do you follow the idea? Give me a thumbs up if you followed the idea of why there needs to be an extra x plus 2 in there. Give me a thumbs down if you're like, oh goodness, that got difficult quickly. Okay. Cool. Okay, let's move on. So the next type of method of factorization is what we call a difference of two squares. And the difference of two squares, basically, if you have a square minus another square, you can factorize it in this form. And I think most of you will remember this, but let's do an example. So let's go 16a squared minus 25. And I want you to factorize that using the difference of two squares method. And just say done in the chat when you're done. So we know the difference of two squares always has this minus plus thing going on. And we know this, in this case, the square root of that will be that. Square root of that will be that. And so that is a factorized form of the difference of two squares. Now, I also want to give you a bonus one, or like one that where there's a bit more excitement. So let me make one up for you. So let's make this 16 a squared b squared minus 4x to the 4 y to the 4. Actually, no, not even that. Let's make it 9x to the 4 y to the 4. Can you factorize that one? And tell me when you're done, when you've done that one. We know it's going to have that structure. We know it's going to be a minus plus. Now, what goes here? 4, and then A, B is going to go there. And here I'm going to get 3. And this is what's sneaky. I'm going to get x squared, y squared. And here I'm also going to get x squared, y squared. Now, why, Mr. S, is that happening? Well, let me show you. If I have 3x squared times y squared times another 3x squared y squared, I will get 9x to the 4, y to the 4. So that's why when I want the square root of this, I get 3x squared y squared, in case that's confusing you. So in going over our factorizing, we have the highest common factor. We always check that first. Then we look for the difference of two squares, which we call dots. That's the shorthand name. The third method for factorizing is factorizing trinomials. So I just say try like that. So let's look at an example like that. Now, there's many ways to do this. And so if you've got a method that you are comfortable with, I'm not going to ask you to change. But at the same time, I do want you to be aware of the different techniques that you could have to use. So here is a trinomial one. Let me just zoom in. Okay, there we go. So if you had to factorize this trinomial, I want to know if you've seen this method before. Maybe you have, maybe you haven't. I start by looking at seeing that it's in standard form, and then I draw a cross for the cross multiplication that happens. Basically, this being multiplied by this and this being multiplied by this. And then what I do is I write down the middle term, which is plus 5. Then I look at the very first term and I say, what are the numbers that when they're multiplied together will give me 9? I only have two choices. I can either have 9 and 1, or I could have 3 and 3, because 3 times 3 is 9, or 9 times 1. Now, we have to choose numbers on this side. Okay? And these numbers come from the constant term. And we ignore the negative, we just deal with 4. Now, we have some more choices here. We either are going to put 1 and 4, or we're going to put 2 and 2 in the box. But when we multiply out, we have to end up with a plus 5. So let's just try out some stuff. I think that, which options should we go for here? Well, I think the 4 and 1 is a good thing to try. So we'll flip. Go back here. So let's go. In some ways, I suppose we can kind of see where this is going because we've got the answer in front of us. Get rid of those. So if we do this, if we have 9 and 1, because we can kind of see the answer, so I suppose let's go too deep. I'm going to choose 4 and 1. But here's the issue. At the moment, with that, it's not going to work. I actually need to put this as 1 and 4. And so what I now need to do is I'm going to say that this is plus, so 9 times plus 1 is plus 9. And 1 times 4, well, I need to make that a negative 4, so that this is negative 4. And together, these add up to the 5. And then when I read them off, when I read off the answer, I go, well, 9x minus 4 is this top line, and this bottom line is just x plus 1. And what we've done is we know that when we go 9 times 1x, 9 times 1x is just this bit here. So we know that balances. Then we know that the minus 4 times the 1 is the minus 4. So that's just this bit. And then the other two parts are just the cross multiplication. Now, I might have confused some of you if you've never seen that method before, But give me a thumbs up if you've seen that method before or you feel comfortable doing this trinomial question. Let me know in the chat. We're going to do some more now to practice this, but I just want to get a feel for what the group has seen and what they haven't seen. Okay, so Siamtanda hasn't seen it, but Stephen has. Siamtanda, could you do it though, using another method? Would you be able to do it using another method? No. Okay, well then let's work at this method because I think it's a really good method. So let's just practice this trinomial method. Let's start with simple ones and then we'll work up to more hard ones. So the way to do it is to go back to the very beginning. Now, if you look at these trinomials, the reason they are a little bit easier is you'll notice there's always a 1 in front, which makes life easier. So I'm going to show you this method, the way it works. So for this one, I know that when it's factorized, it's going to have to look like that. But I don't know what numbers go in here. So what I'm going to do is I'm going to draw this structure that I use to help me. And I look in front of the middle term and I write -1. Now, I need to fill in these blocks with numbers and signs. The good news is, if I need to end up with a 1 here, these can only ever be 1 and 1. And if I have to end up with a 30, well, then the only choices are going to be 5 and 6, or I could also have, let me put that back in. I could also have 10 and 3, or I could have 15 and 2. But I need to balance this middle term. And so what I'm going to do is 5 and 6 are quite close together. So my intuition tells me put a 5 here and a 6 here. But I still need to choose whether it's negative or positive here. Now, because I end up negative, I want the bigger number to be negative. So 1 times -6 is -6. And then 1, now if I made this a negative, I get to -11. I don't want that. I want that to be a plus. So 1 times +5 is +5. And then I ask myself, if I have +5 and I take away 6, I get -1. And now once you've balanced everything, the answer for A is just going to be x plus 5, x minus 6. Now, using the idea that I just showed you as an example, I want everyone to try and do B and then tell me when you're done with B. So we're going to do the easy ones first, and then we'll build up to the harder one. And then let me know in the chat if you've done this before or if this is completely new to you. Because different teachers do it differently, and I like this method because I think it's flexible. The quadratic formula does allow you to avoid factorizing altogether, but it's still a useful skill to have. And there are some times where you can't use the formula, or they say the question is set in a way that it forces you. So let me know in the chat if you've seen this before or if you've never seen it. So just say seen it or say never seen it in the chat. So we're doing B, and the good news is it can only be 1, and that can only be +9. So now the question is, what has to go in those boxes to help me? And it's either going to be 5 and 4, or 10 and 2, or 20 and 1. And because we want to get a +9, I think all of you will be drawn to the 5 and the 4. And then this will become a plus and a plus. So it's 4 and a 9. No, sorry, a 4 and a 5. And that gives me my 9. And so the answer will be x plus 5, x plus 4. Let's do C. I want you to try and factorize C for me using this approach. And then we'll do one more after that, and then we're going to take a break. So you have to ask yourself, what are the factors of 42? So I remember from my times table 6 and 7, or we could have 21 and 2. But it feels like 6 and 7 are in the right part of town because already 6 and 7. So 6, 7. So I'm going to make that a plus and that a plus because together, this gives me a 6 plus 6. This gives me a plus 7. And together, remember the balancing term? Does this add up to that? And it does. And then I can read off x plus 6, x plus 7 will be the factorized form of C. So even if you haven't seen this before, after having seen 3 examples, I'm hoping it's a little bit easier. And now let's have a look at a different example. What is different about G? This is the last one we're going to do before our break. What is the difference with G compared to the other ones that other binomials we've factorized so far? You can raise your hand, or you can pop it in the chat. Let me know what's different about what makes this a bit harder. Yeah, it's the 3. Yes, Amy. Yes, Sange. It's the 3. But the good news is, if you think of this method, you're going to put a minus 7. Now, you're not going to put a 1 and a 1 there. But because 3 is a prime, you can only put 3 and 1 there. So now you have to make some decisions about the next bit. But I'm going to let you do that by yourself. And I want you to tell me when you're done factorizing G. So you remember you have to balance the minus 7. That's your balancing term. But take what you've learned so far and see if this can help you. So 6, it's either going to be 3 and 2 or 6 and 1. So tell me when you're done in the chat. Okay. So I have to try some stuff out here, but I think if I put a 3 here, I get to 9. And now I could be wrong, hey, I check this, but 3 gets me to 9, the 2 gets me to 7. Now I need this to be negative and that to be positive. Let's check. 3 times minus 3 is minus 9. 1 times plus 2 is plus 2. Plus 2 minus 9 gives me minus 7. So everything is balanced, which means I can now read off my correct answer, which is going to be 3x plus 2, x minus 3. And notice how clever this method is, because you can see 3x times x gives me this. And that was just this bit over here. And then what is 2 times minus 3? Well, that's the minus 6, and that's the bit we're doing over here. And then the other two multiplications are built into that cross there. And so I do hope that that this method is becoming a little bit easier for you. We'll do one more maybe after the break, but it's time for us to take care of our brains. So I want everyone's screens on. I want everyone to see each other's happy faces while we're exercising. And I want you to step away from your desk or your table. I'm going to do the same because I know that I have to take care of my brain. Otherwise, my brain won't take care of me. So I want to see those cameras on. Sandile, Amy, Sange, Amakle, Simtada. Don't be shy, I promise. These are your maths family people. You will get to know them very well this year. We may as well break the ice now so that we all feel comfortable. Okay, let's start with a nice deep breath in. Hold, breathe out. Breathe in. One more nice deep breath. Breathe out. Okay, so we got some oxygen. Now let's loosen up. Shake out your hand. Shake out your other hand. Shake out your leg. Shake out your other leg. Shake out everything that you can. Get as nice and loose and floppy as you can. All right. Then put your arms out to the side and you're going to rotate from your hips, but just slowly, just very, very slowly. And then you're going to relax everything. And as you relax, your body's going to turn naturally further. Wanting to be led someone into class. There we go. Okay. Oh, it feels so good. I can feel everything in my body loosening up. Feels so much more flexible and relaxed. Okay, let's do another shake of the arm, shake of the leg. Let's roll the shoulders. Our shoulders get quite tense because we're sitting like this the whole day. So we roll them back. Okay, and then we roll them forward. And then we put them to the side and we do small circles. And then we go backwards, small circles. Okay, then last thing for the break, we're going to do jumping jacks to really get our heart pumping. This is the jumping jack, and we're going to do 15, and then our hearts are going to notice. Okay, 3, 2, 1, let's go. 6, 7, 8, 9, 10, 5 more, 11, 12, 13, 14, 15, and my body feels like it has had a break from maths, which is good. Even a maths teacher needs a break from maths sometimes. So before we move on, let's do a little brain break. And can you tell me what a kitten plus a fox plus a bird is equal to? That is your challenge for tonight. So Sange, I think the kitten is 5. I agree with you. Sure, I can feel my heart rate. My heart's going boom, boom, boom. What is the bird going to be? So the bird is going to be 15. Yes, Amy, I agree. You've got this. Wait, 15 you said? Yeah, 15. Okay. Now, I think this is a fox or raccoon. I'm not sure, but we need to help figure out what that's going to be. Okay, so Sitanda, 55 minus 15 is 40. Yep, all good. So what is a kitten plus a fox plus a bird going to be equal to? Yes, it's going to be 75. Well done. Well done, everyone. Okay, so we've taken care of our bodies, we've taken care of our minds by giving them a fun little puzzle to play with. And now we're going to head back to what we were doing, which is basically we checked our multiplying out, we're checking our factorizing skills, that they are good to go, because you do need to be able to factorize comfortably. I want everyone to try and factorize. What have we done this one here? We did the 3, the -7. Let's do this one. I want you to do H. So everyone attempt. Let's do H next. And then just say done in the chat when you're done. All right. So I'm pretty confident that that part, because the 2 and the -11 are not flexible. They have to be. Let me know when you're done in the chat. That's awesome, Sientanda. Yeah, it gets easier. It's like everything in life. Once you get a good, clear explanation and you practice a few times, most things are pretty good. Okay, that must be a minus. So that gives me -11. That must be a minus. That gives me -1. And so my answer should be 2x minus 1 times x minus 5. Okay. You guys are doing really well. In fact, you're doing so well, I feel like my duty is to challenge you. So let's do J and then we'll move on. So can you factorize J, the one in pink? And then questions and comments I will stand for in the chat. So the only part we don't have a choice for is that bit. But these other bits we do. Now, so here, the 5 actually has to be. So just to make sure we're on the same page, this is the question that we're doing. Now, it can either be 3 and 2 or 6 and 1. Which should I use? 3 and 2 or 6 and 1? Remember, I have to get to 7 in the end, plus 7. Now, if I use 3 and 2, oh, that looks promising, because 2 times 5 is a 10, and then that's a 3. So I think 2 and 3 or 3 and 2 would work well. But let's just make sure this has to be positive. So that has to be positive to give me plus 10. And this would have to be negative. And so we make sure that this and this do balance. So they do. 5 times minus 1 gives me minus 5. Okay, let me know in the chat when you're done with this one. And I'll write up the final answer. So for the pink one, there are going to be 2 brackets. And they are going to say the following. So that is the factorized form of the pink one over there. Okay, give me a happy face if trinomials feel more doable now, and give me an unhappy face if you feel very lost, and give me an in the middle if you're like, okay, look, I'm not like smashing this yet, but I see where this teacher is going with this, and there's hope. So, all right, fantastic. All right. Well, I think you guys are doing so well. I don't want to hold you back. So let's keep going. Now, what happens now is in some of the questions, we have 3 different methods we can use to, well, there's actually more than 3, but the big 3 are HCF, difference of 2 squares, and trinomial. And we normally do them in that order. So we always try to do them first, but there are 2 more. There's something called grouping, which is kind of like a special case of the highest common factor. So it's kind of related to number 1. And then the 5th one is the sum and difference of 2 cubes. So sum and difference of 2 cubes. But these are more rare than these ones. And so because of limited time, I will give you past papers that have them in. But for now, today, there are some examples here. Okay. Now, I want you to try and factorize number 5 for me. Now, we might have to do this as a team. We might have to give each other some help. But I want you to do number 5 and tell me what technique would you start using for number 5. Go team, we can do this. Let's do it. Let's do it. Who wants to give me some help? Where would you start with number 5? Okay, Amy, let's go to you. What would you do?
Yes, sir. Can you hear me?
Loud and clear, Amy. It's so good to hear your voice. What would you do first?
First I'll take out 5 as a common factor.
Okay.
Yeah.
Did you get x squared minus 9?
Sir?
Did you get x squared minus 9 in your other bracket?
Yes, sir. Yes, sir.
And then what would you do?
And then for the bracket, I would do dots.
Ah, yes. Difference of 2 squares. What are they? What are the two factors going to be?
It's x plus 3, and the other bracket is x minus.
Perfect. Thank you, Amy. That was lovely. So what Amy showed us there was step 1, highest common factor, step 2, difference of 2 squares, and now it's completely factorized, which was awesome. Okay. I want us to try this one over here. Go team. So number 7, and I want to know, where would you start if you were going to factorize number 7? A monster. Well, I mean, it does look, but maybe it's like an elephant, like it's a monster, but it's once you get to know it, it's not so bad. It looks like a monster, but actually, as long as it's not hungry or running after something, an elephant is still pretty nice to be around. Okay, Sange has said take out the x as a common factor. I think that's a very good idea, because what do I get left with then? I get 6x squared minus 13x plus 5. Yes, I like that a lot. So what that means is I think you could factorize this one as a trinomial. It's not a difference of 2 squares, but we've taken out the first method, like HCF, and now I think we have to use trinomials. So see if you can factorize that and then just say done when you're done in the chat. No. I'll zoom in so you can all see nice and clearly. So I know that these two have to be 5 and 1. I know this is minus 13. What I don't know is what factors I should use here. But I know I need to get to minus 13. And for me, 6 and 1 seems too big. So it's, I think, 3 and 2. But then where do they go? Does the 2 go here or does it go here? Well, I know that I'd like a 10. And so 2 times 5 is a 10. And that would be a 3. But we now need to put our positives and negatives on this side. And we have to have actually a negative and a negative. Because this will give me minus 3. And this will give me minus 10. And together, those will give me that. And the other thing I need to watch out for is negative 5 times negative 1 gives me plus 5, which is good. So our final answer will be x, open 2 brackets, and then 3x minus 5 and 2x minus 1. Yeah, that was pretty hard. So I'm pretty impressed if you guys are feeling okay about that. Any questions about that one or anything? Anybody need some clarification or comments about that one? Please do raise your hand if not. Otherwise, number 6 is just too tempting. We have to have a go. I want us to factorize number 6. What would be my first step? Who wants to share their thinking with us? Who's feeling generous? They say it's good to be generous in life. Who is going to share their knowledge around? Where do I start with this one? I feel like the 2 and the 16 have a common factor of 2. But then what is going to go inside the bracket? What is going to go inside the bracket? So it has to be x cubed plus 8. Okay, but now here's the thing. Are we done factorizing? Can this thing over here be factorized further? Yes or no? Yes, it can be. This is called the sum of 2 cubes. Now, it doesn't get as much attention as the big 3, but it's still important. And the way it works is you say, what is the cube root of the first cube? Cube root of x cubed is x. Then you say, what is the cube root of the second cube? Well, 8. What's the cube root of 8? It's 2. Then whatever sign is here, you just write down. So that's plus. Then the second bracket, you say you take this first one here and you square it. And what do you get? You get x squared. Then you take this one over here, this plus 2, and you square that. And what do you get? You get 4. Now, the only slightly tricky bit is this next one, the middle term. And what you do here is you go, x times 2 is 2x, but you need to change the sign and it becomes minus 2x. All right? And now, once you've done that, you are finished factorizing. Okay, and so you've learned how to fully factorize this. You took out the HCF for step 1, and then for step 2, you did the sum and difference of 2 cubes. Well, actually, you just did the sum of 2 cubes, but that's the shorthand I use. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. Or give me a happy face, unhappy face. Okay, so just enough time to preview what we're going to do in the next lesson. But I think you guys have done very well today. So in the next lessons, what are we going to do? Well, we're going to talk about we're going to talk about equations. And equations are just expressions like we were doing today, but they have a left-hand side and a right-hand side. So an equation is an expression that just is linked with another expression with an equal sign. And so we're going to talk about putting things in standard form. So that's the one thing we're going to talk about. We're also going to talk about how we solve a quadratic equation by factorizing. So the skills we learned today, we can use to help us solve equations. And then we'll also do some multiple choice questions. That's that. And then we'll start to solve more difficult quadratic equations like this. Okay, but that's enough for one day. Can you see the screen now with the quiz questions? Tell me in the chat if you can see them. Okay. All right. Now, which one did you say was being difficult, Siamtanda? Okay, let's unmute you and see which one you said was not playing ball.
Is this the right quiz? Because there's one that you posted.
Oh, it's quiz 3. Sorry. You're quite right. Hold on. Let me go to quiz 3. Is this looking better?
Yes. It's number
Okay.
3, that one. Number 3.
That one there. Okay.
Yes.
Let me take a screenshot and I'll just do it and then we'll. So I'm going to jump from there back into OneNote and we'll do it together before we finish off today. Okay. So if there was a mistake, we'll pick it up now. So the 1/3 becomes 3 to the minus 1. And this is like this. And the 9 comes to the top. So this is 1/3 squared. But when it comes to the top, it becomes 3 to the minus 2. And then here we have minus 1 plus x plus 1 equals 3 to the minus 2. But the minus 1 and the plus 1 cancel out. And so it should be minus 2. And so the answer should be A.
I made a mistake. I didn't pay attention to the minus 3 behind. I only focused on like that.
But actually, it's a good point. What I'll do is going forward, I'll also if there's questions that are problematic, I can bring them to class. And what we did now is actually brilliant. So thank you for raising that.